Hello, and welcome back to Pulumi TV. This is Modern Infrastructure. This week is another What's New episode. We haven't done a What's New since February, so we've got quite a lot to cover. So much so, we're going to take a look at not 3, not 4, but 5 brand new features the Pulumi team have shipped over the last 2 months. Let's dive right in. Alright, so the first thing we're going to take a look at is some improvements to the Pulumi import command. In order to show you this in a rather visual way, what I've done is I have downloaded an old Pulumi binary. You can see this is version 3.25.1, whereas my most up-to-date version of Pulumi is 3.30. And we're going to do this with both versions so you can see the improvements. Now, I have a small script called import.sh, which just uses the Pulumi old command to import this instance. Some random, generic, arbitrary EC2 instance. I don't even remember what base image I set. Not really important. What is important is that if we run the import sh command, is that the Pulumi program is going to go fetch some information from AWS and try to bring this into our stack. However, it's going to fail. And the reason for this is covered in much more detail in a blog post, which the link is in the show notes below. You can go read that from my colleague Fraser. But what's really important for us to take a look at today is that it's fixed. All right. So let's copy our import command and use our new Pulumi command. And we can see that this can be successfully imported. Wonderful. And now that that's finished, the Pulumi program has told us that this is a code that we need to put into our Python Pulumi program to persist this state. So some wonderful improvements there to import. If you've used it in the past and you've had problems, try it out now. We hope that it's solved a lot of those older problems. All right, new feature 2. This time we're going to take a look at retain on delete. What is that, you say? Well, we have a Pulumi program here in Go. This Pulumi program is relatively trivial in that all it does is deploy Nginx to a Kubernetes cluster. However, on the custom resource options, we're now using the Pulumi.retain on delete true. Now, this is exactly what it sounds like. When I run and apply this stack, it will create my Nginx deployment. And when I run a Pulumi destroy, even though the deployment is being removed from our state file and our stack is essentially destroyed, the resource was created with a retain on delete. And what this means is when I run kubectl get deployments, we're still going to see our deployment that was created 28 seconds ago by the Pulumi program. This is one of those features that people ask about a lot as an alternative to protecting certain resources within the stack. But retain on delete allows you to use Pulumi in new, ephemeral, one-time run scenarios. So check it out, have some fun, and let us know what you're using it for. All right, feature number 3, better diff support. Now this may not sound very exciting, but I am thrilled with this addition to Pulumi. So let's take a look at what I mean. This time we're jumping into a JavaScript project, and we've got some more Kubernetes resources. The first thing I'm doing is creating a config map with some deeply nested things. In fact, we have a value here of 1, which I'm going to increment to 2. And if we drop down to our deployment, you can see that we have more deeply nested things, only this time less contrived. And what I'm going to do is change our image to 1.14.2. Now I've already spun up the stack before, So we're just going to do a Pulumi up, and this time it's going to tell us that it needs to change our config map and our deployment. When you see this screen, we do have the ability to see that the diff changed on the data in the config map and something on the spec on the update. It's not until we jump into the details that we see more information. Now, before I show you what it looks like new, let's try old. So this time I'm going to do a preview diff to go straight to the details view. And what we'll see here is that we do get a decent understanding of what changed on the image. We have the red of the old and the green of the new. And this is because Pulumi has a pretty good understanding and a strict specification for that object. However, with the config map, where we're actually working with JSON data, then all we see is that we have a large string that looks structured that has been replaced by another large string that looks structured. And in fact, it is really difficult to see where the 1 has changed and the 2 has been added. So if we use new Pulumi, and this time we'll run the preview diff again, we're going to see something a little bit different. We still get the great support with the image annotation here, just showing us that this is actually an additive green string. We haven't actually removed anything. So previously it says Nginx was removed and this was added. So the diff is slightly more advanced. Not only that, is that it understands the deeply nested thing. Even though it's a string, even though it's just a string, it knows that it's JSON, and it knows that we have a key thing which is deeply nested where the value has changed from 1 to 2. Your notifications and comments on your CI/CD process are going to give you much better visibility into the changes that are actually happening within your Pulumi program. Okay, let's take a look at the fourth new feature. This one is special to me because I have been complaining about this behavior for a long, long time, and that is pending operations. What do I mean by that? Well, I've prepared a very, very contrived example to show you. The first thing I'm going to do is run Pulumi up. This is going to create a random resource, essentially. It's a dynamic provider that I'll show you in just a moment. And what's going to work just fine here is this entire create process. We do have some output that tells us that the create process slept for 0 milliseconds, and that's very intentional. So everything here looks good. So what I'm going to do is make a small change to our program. And you can see the dynamic provider here. Actually, it will do a sleep on a create and on an update so that we can get into a certain situation. And down here, we have a very high sleep threshold set on the update. So what I'm going to do is change the threshold on our create to the equally high number. And using Pulumi old, I'm going to run a Pulumi up. So I'm going to accept that this update can be applied. And this is now going to sleep for a long time. In fact, we can see sleeping in the diagnostic logs here. But this isn't going to finish, at least not in an acceptable time for me to complete this video. So I'm going to do something that I'm sure we've all done in the past. Control C.
No, God! No, God, please, no! 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 No!
We're now in a situation where Pulumi attempted an update operation, and for whatever reason, whether an error on a remote API or the user has explicitly killed the process, we're in a situation where Pulumi may or may not have applied an update to a resource. And this gets us into a situation where if we wish to run the Pulumi up again, we're going to be informed that, hey, actually, you can't do this because there are pending operations within the state file. The state file logged that the update operation was started but never completed. And the only way previously to get rid of this was to run a Pulumi stack export to a file. We can then jump into this file, search for pending operations, and we'll see that our resource and the operation pending. And we had to delete this every single time. Now I'm not going to save this file, and instead just confirm that we're still in the broken state. So we'll use Pulumi old, and we'll do a Pulumi up yes, just to skip the prompt. We should get the error that the pending operation is still there. With the new version of Pulumi, this is from 3.2.8, I believe, is that the Pulumi program is not going to consider a pending operation, at least an update pending operation, to be a deal breaker, and then try to update a resource again. Now, of course, this is going to fail because we still have that very annoying extended sleep delay. So let's change these back to 0. We'll run Pulumi up one last time with -- yes. Now, we do get a warning telling us the pending operation is in the state file, and that if we run a Pulumi refresh, that will be cleared. So we can run Pulumi refresh. Now, it's important to note there is a caveat on this warning. Let's just say yes. And that create operations will never be cleared from the state file. They are no longer blocking. They will not stop your CI/CD process or your ability to run Pulumi up commands, but they will remain in the state file. And this is a warning or a reminder to you that at some point during a create, Pulumi may or may not have created a resource. Now, the team are investigating ways in which we can also handle failed or delayed or killed create processes. It's a work in progress, and hopefully we'll have an update for you again soon. But this is a very welcome change. I'm super thrilled with this. Thank you to all of the team that put this together. Okay, number 5 and our last new feature for this episode of Modern Infrastructure. AWS recently launched Lambda URL functions. This means it's never been easier to deploy a Lambda that has an HTTP endpoint. Okay, so let's run through the code quickly. First, we have a Lambda role and a Lambda role attachment. If you've deployed Lambda functions before, this will not be new to you. However, I'm not going to go over it in any more detail. If you want to learn more about this, check out the blog post in the show notes below by my colleague Kat. Once we have the appropriate role and role attachment, we create the function. Now, we're doing this nice and easy. We're just going to do an inline function that has a response of hello world, and Pulumi's going to handle the rest. Sweet? Yep. Next, we're going to say that we want a new AWS native Lambda URL. It just takes the function ARN and we tell it that the authentication type is none. We're going to make this a public URL available to anyone. Now, I've got a little bit of code here commented out because of a small change in the AWS API, which will be resolved soon, and this will no longer be required. But you will see me execute this command on my terminal, although you could bake it into your Pulumi program too. We then export the URL so that we can curl our function. So I'm just going to run a Pulumi up and give Pulumi a couple of minutes to create everything that we need for our Lambda URL experiment. All right, let's try the curl one more time. This time we get hello world. So AWS Lambda URLs make deploying Lambda functions with a public or private HTTP endpoint much, much simpler. So that's it for today. We hope you like these updates to Pulumi. There's plenty more coming. In fact, just next week on May the 4th, 2022, we have our Pulumi Up conference. Links are in the show notes. Register now. We have some amazing things to share with you. We hope you enjoy these videos. Please remember to subscribe, like, and if you have any questions, drop straight into the comments. We're always happy to help. Until next time, have a wonderful day. I'll see you soon. Adios.